Hi guys, you see that in the middle of the screen, this is the topology graph of our group. And the way of drawing it is quite similar to what happens in our laboratory work. It's in fact begin with one place, for instance, the bus 1, and just search the RDF name and RDF resource step by step. You can find out what is connected to our beginning point. It is first a node and then the breaker and the node and the element, etc. And using this way, you can step by step, one by one, to get a whole net of our state grid. And this is the way of getting the topology. But I think the aim of our project is in fact the totally automatic work. And to get this point, to make all of the work automatically done, we have to get the help of the Java, and this is our aim. But you see that I show you the topology graph. It means that some part of the work is done by our human beings, and this is not our aim. So in order to improve that part, our group have some of the methods. Our thought is that just similar to the human beings working procedure, we just start from one point to another place, and from the bus 1 and from all the buses. And we can make a cycling in Java, and to do this kind of work, start from all the bus and step by step. And when your process reach an element which read by the Java, it proves that it is another bus and we have to stop. It means that this bus can get access to all the elements directly connected to itself. And next step, when the cycling goes on, and we can do the same things with other buses. Using this way, we can just get all the graph done and without missing anything, because we have include everything connected directly to the bus, and we did not miss any of the bus. So the whole of the topology will be done by Java. However, we do not have access to draw this kind of things directly, and the result of the Java code is in fact the connecting relationship between the bus and the elements. And for this part, my groupmate will give you a more detailed explanation in his part. And now I want to show you our way to get the Y matrix of the power system. And the Java code is in fact divided into several parts. The first part is get the information we need from the XML document. You see that here is the code of doing that kind of things. I define the thing we need, the real part of the AC line and the image part of the AC line. And also here you see that the shunt capacity of the AC line, and also here is the load and the transformer and other kind of things. But there is a interesting part of this part of the code I want to show you, is that you see that in the XML document, not all the information is useful. For instance, the transformer end, you see that this is the first one, and here is the parameters we need, the resistance, the real part and the image part. So it is good. But the second one, oh my god, they are 0. So you see that the information in this document is not useful for us. So this is a problem. And if we do not recognize this kind of things in the Java and it means that we may get the wrong information. We can get the things are not useful as the parameters. So in order to avoid that, I do more detailed explanation here in my cycling. I show you that the first one, the third one, and the fifth one is useful, while others are not. So I just pick them up here, the first one, and third one, and the fifth one. And I think this is a bit of pity for me, because I think I can judge what is useful and what is not. But if I want to do the whole project with a totally automatic way, I do not have to need. I should not just add my thoughts in it. But okay, this is the part. And for the other part, I do not think it's very interesting, because they have the similar way of running. So let's jump up to the second part. The second part is the calculation of complex number. According to the Java variables, we do not have a variable called complex by the Java itself. However, according to the power system analysis knowledge, we have to do the calculation of the complex number. So we have to introduce a method of doing the complex number by ourselves. And here is the way we do that. We just judge a double number as the real part of a complex number. We'll judge another double number as the image part of our complex number. And you see that here we give ways to do the adding and the minus and the multiplying and the dividing of the complex numbers. And you see that this is in fact the common mathematical knowledge, so I will not do more explanation on this part. And since the complex is a new variable of this, and we just get it in, and you see that during the process, I just specially divide my parameters into the real part and the image part, because it is written in this way in the XML document. So I just do them. And I want to point out the interesting part is that the complex number, the way of defining it is a bit of different from the variables like integer or double, because complex is a totally new thing. And according to the method I introduced, I have to give the real part and the image part here. And if I know the image part and the real part of a complex number, and I can define this number, give this value to my variable. And if it is not directly, we do not know the real part and the image part directly. For instance, according to the XML document, we know the voltage and the power of the load, but we do not know directly about the information of the resistance of the load. So we have to do the calculations according to the method I have introduced here, dividing and multiply the voltage and voltage itself and divide it with the power. So we can get all the information we need. And for this part is a matrix. The matrix, we define all the elements of it according to the power system analysis, and it is not that tricky because it is easy, because just adding up the resistance, I think maybe the resistance, using 1 divide the resistance and adding them together between different nodes or the node itself, and we can get all the elements of it. And since we get the elements of it and run it, just print it out and we can get it. At first, I use a quite awkward way of doing so. I just one by one print them, and one space and the other and the other and the other, and every file one it goes as a line, and I use an enter and a new line, and it happens to be a mess. So I try to make it neatly and to use a way of just multiple multiple arrays to do that. But although I transform the variable of the complex to the string, the variable string, you see that the real part I change it into a string, and the image part I change it into a string. And here I add an j multiple, and I think should be a plus. And this got a string of our complex number, and that's what we need. And I can run it for you. Oh, although I successfully reached it with the arrays, but as a matter of fact, you see that it is also a mess. Oh, so it's a pity. But at least it is a matrix, you can see, although it is not neat enough. So this is my brief introduction of my part, and thank you everyone. Just expect the part of my teammate. Thank you.